Hey everyone, and welcome. Have you ever just stopped and wondered what the universe is really made of? At the deepest, most fundamental level? Well, today we're going to look at two incredible and totally competing ideas that are trying to answer that exact question.
You see, for decades now, physicists have been on this epic hunt for a theory of everything. One single, beautiful equation to explain it all. But what if the real answer means we have to completely tear down our ideas about space, time, and, well, the fabric of reality itself?
So let's meet our contenders. In one corner, we have the reigning champion, the famous string theory. This idea says that reality is like a giant cosmic symphony made of tiny vibrating strings in extra dimensions we can't even see. And in the other corner, we've got a bold new challenger, dynamic vacuum field theory. It throws out a much simpler idea, that everything we see is just a ripple or a knot in one single physical field.
All right, so here's our game plan. First, we're going to dive into that musical universe of vibrating strings. Then, we'll explore the cosmic ocean of this single field theory. After that, we'll see how they stack up against some of the biggest puzzles in physics. And finally, we'll ask a really important question. Which one of these just makes more sense?
Okay, first up, let's talk about the theory that has really dominated physics for the last few decades. Let's talk about string theory. The core idea here is actually really elegant. It says that the most basic building blocks of our universe aren't little points. They're more like tiny, tiny guitar strings. So everything, the light from the screen you're looking at, the atoms that make you up, is just a different note being played. It's a unique vibration of one of these fundamental strings.
But, and this is a big but, here's the catch. For all the math to actually work out, the theory needs some pretty wild stuff. We're talking at least 10 dimensions. That's a regular 4 that we know and love, plus 6 others that are curled up so impossibly small that we could never ever see them. And while it does predict gravity pretty neatly, this total reliance on things we can't observe is exactly why some critics say it's more like mathematical philosophy than actual physics.
So, what does that really mean? It means that string theory is asking us to accept a reality that is fundamentally abstract. It's a universe that's really just a symphony of vibrations playing out in hidden dimensions that we can never, ever experience directly.
All right, now let's switch gears completely and look at the challenger, dynamic vacuum field theory, or DVFT for short. This theory just throws the whole idea of extra dimensions right out the window and starts from a totally different place.
DVFT asks you to imagine that the universe isn't just empty space with stuff in it. Instead, imagine it's a vast dynamic ocean of energy. A single physical field that fills everything. So every particle, every force isn't separate, it's just a feature of this ocean. It could be a wave, a little whirlpool, or maybe a stable knot of energy. The real beauty here is its simplicity. It all works in our familiar 4 dimensions, no hidden ones required. Particles, forces, maybe even space-time itself are all just different behaviors of this one fundamental thing. It's kind of like a perfect fluid where everything we see is just a different kind of disturbance within it. And this really gets to the massive philosophical shift that DVFT represents. Instead of starting with incredibly abstract math and hoping it lines up with reality, it starts with a physical concept, a tangible medium, and tries to build the universe up from there. It's a completely different way of thinking.
Okay, so a new idea is cool and all, but the real question is, can it actually solve problems? Let's put these two theories head to head and see how they deal with some of the biggest, deepest mysteries in all of cosmology.
Let's kick things off with black holes. String theory uses some incredibly complex math to handle them, but DVFT gives us a more physical picture. A black hole is just a spot where this vacuum field has been literally drained away, which gets rid of the need for a weird singularity at the center. Next up, why don't protons decay? We've never, ever seen one do it. Well, string theory can be tweaked to make that work. But DVFT? Its structure predicts that protons are just naturally stable from the get-go. And finally, the energy of empty space. String theory has a mind-boggling number of possibilities. We're talking 10 to the 500, and we have to pick just the right one. In DVFT, that energy just emerges naturally from the field itself. No fine-tuning needed. Okay, so we've looked at the physics. Now let's step back and look at the philosophies behind them. And this brings us to a really fascinating and frankly, very human question. When you strip away all the super complex math, which idea just makes more sense? Which one feels more intuitive to you? Is reality ultimately built from pure abstract mathematics? Or is it made of some kind of tangible physical substance?
Look, here's the bottom line. String theory is mathematically brilliant, but its core ideas, like those extra dimensions, are things we can never possibly see or touch. DVFT, on the other hand, just feels more grounded. It's based on the idea of a physical medium, which is something we can all understand, right? We know that sound waves need air to travel, and ocean waves need water. So why shouldn't particles and energy also need some kind of cosmic medium to exist in?
And that really leaves us with the ultimate question, doesn't it? As we keep searching for that final theory, should we be following the path of pure mathematical elegance, even if it leads us to a reality that's totally unobservable and counterintuitive? Or should we be looking for an answer that's grounded in a single, physical ocean of energy, from which everything we see and touch emerges? The debate, you can be sure, is far from over.